Hello everybody. Now let us solve the third sum. I've read out the sum. The address of a class B host is to be split into subnets with 6-bit subnet number. What is the maximum number of subnets and the maximum number of hosts in each subnet? Okay, this is a problem. So they have given a class B host. So what will be the number of bits in the class B? For class B, see class B, here the number of network bits and number of host bits will be equal. Okay, so what is the number of host bits? Host bits will be 8.8.8.8 here. These are the network bits and these are the host bits. Okay, in class B, this will be the case. So they have given that the address of the class B host is split into subnets. So they given the what is the number of bits for the subnet number. So number of bits in the subnet number in subnet is 6. Okay, so subnet value they will take from the host only. Subnets are taken, the bits are taken from the host only. So the network will not be where there will be no change. So only the host, the bits will be taken from the host for the subnets. So they are specified that they have taken 6 bits. So already in class B we have 8 plus 8, that is 16 bits for the host, and now they have taken 6 bits. So from this they will take 6 bits. So here we will have 6 bits for the subnets. So if we take 6 bits for the subnets, then they are asking the what is the number of subnets. So what is the maximum number of subnets? Maximum number of subnets. So if it is 6 bits are used for the subnets, then how many subnets will be available? Because it is a binary value, so it can be 0 or 1. So number of subnets will be 2 power 6. So what is 2 power 6? 2 power 6 is 64. But we cannot write 64 because we have to subtract the 2 from it. That is 64 minus 2, which is 62. Why so? Because for each in the host we have to subtract the 2 addresses for what? For network ID and broadcast ID. For network ID and broadcast ID, we have to subtract 2 addresses. So we have 64 minus 2, which is 62. Next, they are asking maximum number of hosts in each subnet. So what will be the maximum number of hosts? Maximum number of hosts is number of bits for the host. So what is the number of bits for the host? Here we have total 16 bits for the host, but here we have taken 6 bits for the subnets. So 16 minus 6, that is 10. So for hosts, how many bits are available? Only 10 bits are available. So then what will be the number of addresses, or what will be the number of hosts? So it will be 2 per 10. So number of hosts will be 2 per 10, which is 2 per 10 is 1024. So here too we have to subtract 2 because of the network ID and broadcast ID. So 1024 minus 2, which is 1022. So this is the maximum number of subnets and maximum number of hosts. Okay, next problem. The representation of a 4-bit code 1101 into 7-bit even parity Hamming code is. So this is the problem. The representation of a 4-bit code 1101 into 7-bit even parity Hamming code is what? So they given the code, that is Hamming code problem. Okay. Here they given that the data 4-bit data, that is 111101, it has to be converted into a 7-bit Hamming code. So how will the Hamming code be actually? Hamming code is with the redundant bits. Redundant bits means we add parity bits. Here it is given as even parity, 7-bit even parity. So we have to add the parity bits in such a way that is in even parity. So first you need to know that in Hamming code what is the condition. The condition is, suppose there are d bits. D is the number of data bits and R is the number of redundant bits. Redundant bits means which add we add for error correction, no? So these are redundant bits. So here in Hamming code we have to have a, how we'll have do the Hamming code is we'll add redundant bits with the data bits, and then we will check the for the correctness of the data bits. So for this we need to have the condition. So how much redundant bits we can add, what bits we can add. So we have to form the formula. So the formula is, this is 2 per r should be greater than equal to r plus d plus 1. So 2 per r, this is the formula. R is the number of redundant bits, d is the number of data bits plus 1. So 2 per r. So in 2 per r should be greater than r plus d plus 1. Here they were already given 4 bits. 4. So d is 4 bits. The data bits are 4. Now how many redundant bits? Already they given in problem itself 7 bits. So redundant bits will be 3. But we can check also from this formula. If you put r is 0 means, then here r is 1 means we will not get the value. Only if you put r is equal to 3, we get 2 power 3, which is r is 3 plus 4 plus 1, which is 8. So 8 is equal to 8. So this only satisfies condition. Any value less than r3 will get lesser value only. So it won't be satisfy this condition. This condition should be satisfied. So next we'll form the Hamming code. So another one thing, these redundant codes have to be, then bits have to be added in the in what places is 2 per r positions. That's 2 per r positions. So we write the data bits. So data bits are 1101. So it is a 7 bit. So write the 7 bit. Here we'll take the same. Here that is first position, second position, third position, fourth position, fifth, sixth and seventh. Okay. So the redundant positions will be 2 r positions. We take r from 0, 1, 2, etc. So we have only r3 values only. So if it is 2 per 0, 2 per 1 and 2 per 2. So what are the positions? So 2 per 0 means first position, 2 per 1 means second position, 2 per 2 means fourth position. So from first position, second position and fourth position is the parity bits, and the next other positions are the data bits. So here we'll mark here 1, 2 and 4 for the parity bits. We'll fill in. Now they write the data bits 1, 1, 0, 1. Fill in the other positions. You fill in the next other positions. So now we have to find out what is 1, 2 and 4. So to find out the parity bits, we have to take the values. How to fill in the values? Here we will take, see, for the first bit says let's take parity 1. So parity 1 we have to choose, see it is 7 bits, right? So write values in binary 0 1 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. So see, for the first parity you take the bits which has 1 and the last position, that is in the right. Okay. So this value, this value, this value, and this value. What is the value? Is this 1, 2, 3, 4, 5, 6, 7. So what are the values? In which the 1 is the last position. Last position 1, 3, 5, and 7. So take the values 1357 and check the value of 1 to write the value of 1. So how will you check? See 1357, 1 no value, so leave it. So 357 what values you have? You have 315 1 bit 7 1. So you have to write this value based on these values. So here you see that it is a even parity. Even parity means number of ones should be even. So here we see 3, 5 and 7. This is odd. This because 3 bits are there. 1, 2, 3. So 3 bits are there. So it is odd. So you have to add a parity bit which is 1. So P1 value will be 1 because only if you add 1 means it will make this as an even parity. So you have to add 1. So similarly for P2. P2 take the next digit. See next value to next value where one bit is found. So here 2 is found. So take this value. Here 3 also you can take this value because second bit 1. Next sixth question because it is one value here and 7. So what value I told? 2, 3, 6, 7. So 2, 3, 6 and 7. So 2, 3. So 2 value can leave. 3, 6, 7. So 3, 6 and what is the value? See 3 value 1, 6 value 0, 7 value 1. So there are 2 ones, right? So already it is in even. So if it is in even number of ones means what we have to add the parity bit is 0 because already it is even only. So P2 is 0. Next P3. P3 we have to take the last question. So it is 4, 5, 6 and 7. So which are all digits? Here the last place is 1. So 4, 5, 6 and 7. So 4, 5, 6 and 7. So find out the values. 4 no values there. 5, 6, 7. 5, 6, 7 also we find that 5 is 1 and 7 is 1. So it is even. So we can write that P3 parity is also 0. Now fill in the values. Here we have to fill in the values. P1 is 1. P2 is 0. P3 is last parity is 0. So the required Hamming code is 1010 1010101 1010101 is the answer. Let me tell you that we have taken parity bits from the left. We can also take from the right. Okay, we can also take 1, 2, 3 values from the right. That is, can even write like this. That is, we can have taken parity from here, no, 1, 2, 3 like this. Can even write the parity from the left side, this side also. Can accordingly we can write the data. So in some questions it will be asked. So based on the answers you can find out the you can do the problem. Next problem. See, an organization granted block 130.56.0.0.16. The administrator wants to create 1024 subnets. Find the number of addresses in each subnet. Find the subnet prefix. Find the first and last address of the first subnet. Find the first and last address of the last subnet. Find the subnet mask. So this is the question. So let me write it. See, this is CIDR, that is classes interdomain routing routing method. So 130.56.0.0/16. So this is the block. Here in CIDR, that is CIDR classes means classes addressing. Classes addressing. Here we have an octet cells, 4 octet, as it's 32 bits only, similar to the classical addressing as we saw in the previous problem. But here they are given 16. So 16 means refers to the number of network bits. So network bits is 16. So this is also 8 8 and 8 bits only. So here these two, that is 16 bits, are for network. They specify that this is for network. Now they want to create 1024 subnets. They given the number of subnets. Given number of subnets is 1024. Number of subnets is 1024. So from this we can find out what is the number of bits that is used, because I told you that because 2 power x is the number of subnets. So 2 power x is 1024. So x will be 10. So 2 power 10 is 1024, right? So x will be 10. X is what? The number of bits that is borrowed from the host. So host we have only 16 bits, right? Because network is 16 is given. So host is 16 bits only. So from 16 bits, 10 bits are given for the subnets. So here 10 bits, if 10 bits are given means then this one fully is a subnet, and then from here 2 bits are used. So it is 130.56 dot. If you have the more bits, here 8 bits are there. 1 2 3 4 5 6 7 8. So 8 bits are used for subnets, and then another 2 bits from the next host also it is used. So there are 10 bits from the host. Okay, so they are asking find the number of addresses. Find the number of addresses in each subnet. Okay, number of addresses in each subnet. One second. Extremely sorry. Okay, number of addresses in each subnet. Okay, so what is the number of addresses? Number of addresses is the number of hosts. So whenever they ask number of addresses means number of hosts. So what is the maximum number of hosts that can be accommodated? So here, what is the number of addresses can be there can be in subnet. So in subnet, there are 8 bits. So the all the 8 bits, what is the remaining host is only 6 bits, right? For the host only 6 bits are, these are all for subnets. These are all subnet bits. Then the host bits will be 1 2 3 4 5 6. Only 6 bits are for the host bits. Okay, so when there is only 6 bits for the host means then the number of addresses that can be generated is 2 power 6. So what is 2 power 6? 2 power 6 is 64. So you can say the number of addresses for each subnet will be 64 addresses. Next, what is the subnet prefix? What is the subnet prefix? So here the network bits will not change. It will be remain the same only. 130.56 is given. So this network does not change at all. Only from the host only we are taking bits and we are finding the addresses. Here the network bits are not changed. Hence the subnet prefix is 130.56. So this is the subnet prefix. Now next, find the first and last address of the first subnet. So last subnet, you have to find out the first and last address. So how to find the last subnet? So one tip I'll give, that is they ask is last subnet, first subnet. Okay, last subnet, first subnet means first means all the 0. So remember first means all the bits are 0. Last means all the bits are 1. That's it. Okay, so last, so last subnet will be 1, right? First we find out the first subnet. First we find out the first subnet. What will be the first subnet? First subnet means on the subnet all the values will be 0. Okay, That is the meaning of first subnet. All the values will be 0. Last subnet means all the values will be 1, because we are adding the values one by one. First it will be 0, then 0 1 1 0, like that will be going on. So the first address will normally be the all values are 0. The RC first address means it will be all values are 0. Now the first subnet what will be there? First subnet what will be there? It will be all zeros. And then what is the first and last address? First subnet I found out. Now what is the first address? What is the first address? First address also in the host bits we put all as 0 means that is the first address. Last address means we'll put all the host bits as 1 means that is the last address. Okay, so now we'll find out what is the uh, first address of the first first subnet. What is the first address of the first subnet? What is the first address of the first subnet? So here we have to put first subnet and as well as first address. So what will be the value? Here already 130.56 will be remain the same. Next, this all values will be 0. Can write it as 0. Then here host bits also 0 because this is the first address, right? So host bits also will be 0. So these two will be 0. All these will also be 0. So first address of the first subnet is 130.56.0.0. Now what will be last address? Last address of the first subnet. So it is first subnet only, but the last address. So what is be the last address? So last address will be when all the host bits are 1. So but others are 0. Okay, these are 0. Just we'll write it and then we'll say so 130.56.0 because all these are zeros only. Next, these two also 0 only. So next to 2 bits 1 2 3 4 5 6 7 8. Of these two are subnets. So because it is the first subnet, so these two bits will be 0. Now next to 6. So next 6 bits will be what? It will be 1 because this is a last address. So this will be 1 3 4 5 6. So here it will be 1. So what will be this value? That is, it will be 130.56.0. This value, that is 111111. So what will be this value? Can find out this value. This 1 2 4 8 16 32. If you add these values, what will get? Next value is 64. One tip is, if you have next value is 64 means then addition of all these values will be 63. So you can write 63. So this is the last address of the first subnet. Next we'll find out the first and last address of the last subnet. So first address of the last subnet. So when it is a last subnet, what you'll write? You will write the value as 136 will remain the same. Now what are the subnet bits here? See, the subnet bits are here. Now these are, we have filled here zeros. Now we have filled, now to fill ones. So if you fill all ones, that is 1 2 3 4 5 6 7 8. So to fill all ones means it is 255. Next these two bits also 1 double 1. Then this is the first address, right? This is the first address of the last subnet. So when you have the first address of the last subnet, so first address means what? Host bits will be 0. So write 0 till 0 1 2 3 4 5 6. So what is this value will be? This value will be, just you have to find out the value. See, 1 2 4 8 16 32 64 and 128. So 64 and 128 will be, the 64 plus 128 will be 192. So that is the value will be 130.56.255, because all ones means it is 255, and then 192. So this is the value. Next, last address of the last subnet. So what will be last address? Last address you have to put all as once. Okay. So 130.56 dot, this is all ones, so you can write directly as 255. Next also this will be one only, one, and all ones will be there. All host bits are ones, so it will be 1 1 1. So it is only 256.255.255. This is the first and that is the last address of the last subnet. So all are ones. So I hope you understood how will you find out the first subnet and last subnet. Now will you find out the first address and last address. Okay. Next we'll see find the network mask. So they are asking the subnet mask. So we find out what is the subnet mask. What is the subnet mask? So what is the subnet mask? Actually, what is the mask? Mask means, you have to know that mask means all network bits will become one. That is network bits plus subnet bits. Outside network bits and subnet bits will become one, and all the host bits will become 0. So that is a subnet mask. So here for this value 130.56 dot, now see this one, this is 8 bits, subnet bits only. So what will happen? This will become 1. So these values will be 1, and then all host bits, so it will be 1 1 1 1, and then there is the subnets, and then all the host bits will be 0. So 1 2 3 4 5 6, this value that I found out actually, and these also it will be as ones. It will not be 130.56. Okay, it will be what? It will be 255. It won't be 130. It will be two, all ones only will be there. So 1 1 dot 1 1 0 0 0 0 0 0. That is, this value is 255.255.255.192. So this is the value of the subnet mask. Okay, I hope you have understood. I need your feedback on how this video is, and we shall continue with the next unit in the next session. If you have any doubts, or if I am not able to explain properly, or if you are not able to understand means, please write in the comment section so that I can improve my videos in future. Thank you.